Hello everyone. This is a video for the homework number 2 because some students asked me about how to solve for the 3 problems correctly, and I think I just want to go over the 3 problems here and give you some detailed hints, and then I hope this can help you to solve the problems. So the first problem is 2.6. Let's see if my pen works. Okay. So it asks you to determine the x and y components of the force F. So in the picture, there is a cantilever beam attached to the wall. Okay, and then on the end of the beam there is a force which is F, and the magnitude is 1,000 pounds. The direction is shown on the picture, and the angle is given by the slope, which is 3/4. Okay, so that's all the condition. And the question is solve for the x and y components, fx and fy. What's the magnitude? Okay, so to do that, we said first we want to set up the Cartesian coordinate system. Okay, so let's just do it, because this is the horizontal and vertical case, because you see there is already a x-axis set up in the problem. Okay, so just to set up the x as is, and then the y-axis will be perpendicular to the x always, right? And then the O. So the O in this problem, it's also called A, so that's the point of action. So you can also label it as A here, okay? And then the next step is to draw the force. The force is F, 1,000 pounds. So draw it as is. And label it F equals 1,000 pounds. The next thing is, because you are looking for the x and y components, so first you need to draw the x and y components, right? So the way you draw it, we said you need to draw the line perpendicular to x and y, okay? And then think about the direction of the force. Let me try another color. So this is a component. So this force is going downward to the right, right? So some of the force is going downward, like this black force, and that is the force along the y-axis, so it's Fy, and some of the force is going to the right. So there is another component called Fx. So that is your 2 components. And the next thing is you want to build up a right angle triangle to solve for the problem. Okay, now there's no angle given, but there's a slope given. So we said this kind of slope is just like a similar triangle. So first you need to know, in this small triangle, the hypotenuse is 5. Okay, if you don't remember what is the hypotenuse, you can just calculate it from this equation. So the hypotenuse is square root of the sum of the square of the 2 legs. Remember that? So this is square root 25, so the hypotenuse is 5. Okay, that's where you get this 5. Next you want to find the similar triangle in the fourth triangle. Okay, so if you move the Fy to the left side like this, you can easily tell that this triangle is the similar one to this smaller one. Okay, So that's how we solve for the problem. We use the similar triangle characteristics, and we said for similar triangles, the ratio of the corresponding sides are the same. Okay, so now you have to look at the corresponding sides. You can also label it as Fy. Okay, so corresponding sides, Fy, what is its corresponding side in a smaller triangle? It is 3. And it equals to Fx over its corresponding side in the smaller triangle, which is 4. And it also equals to the hypotenuse of the bigger triangle, which is F, over its corresponding side in the smaller triangle, which is 5. So that is your main equation to solve for the Fx and Fy. Okay, so from this equation, you kind of have two equations. You have Fx over 4 equals to 5 over 5, F over 5, right? And F is given, so it equals to 1000 over 5, okay? So in this equation, you only have Fx as your unknown variable. You definitely can solve for this problem. So what is Fx? That's your turn to solve the problem, okay? And another equation including Fy is Fy over 3 equals to F over 5 equals to 1000 over 5. Okay, so you can solve for the Fy because Fy is the only unknown variable in this equation. Okay, so that's the hint for the first problem. And now let's move on to the second one. So second one, it's a hook attached to the wall or to the ceiling, okay? But on that hook, the force T is an angled force, okay? So it's not vertical force. It's an angled force, so because the force is going to the downward, but a little bit to the right side. So some of the force is going down. So if you can imagine, if you're pulling this way, some of this force is pulling this way, right? And some of it is pulling to the right. That is exactly the component of the force T, okay? And what is given here is a maximum withdrawal force of this hook is 250 Newton in the vertical direction. So because this hook is attached to the ceiling, so the ceiling over there, you can imagine the hook have some part of the hook inserted into the ceiling, and that there are some force, resisting this hook to fall down, okay? And that resistant force can resist whatever force on this hook going down. And the problem tells you the maximum force it can afford is 250 vertical direction, which means this resistant force maximum is 250 Newton. If you have any vertical force going down bigger than 250 Newton, this hook is going to be pulled out from the ceiling. Okay, so for this, you want to make sure the force going downward, the vertical downward direction, you want to make sure that force is smaller or equal to 250 so that the hook can be safely attached to the ceiling as is. Okay, then now can you calculate what is the T? Because we only know that whatever vertical force generated by T should be smaller or equal to 250. Then what is T? Okay, that exactly what's asked by this problem. So the first thing is we still need to draw the Cartesian system and find the components of the force T. So let's just draw it. This is a horizontal ceiling, so we don't have to worry about the angle thing. We still have the x as horizontal line and the y as the vertical line over there, okay? And now we want to use the action, the point of action as our origin in the Cartesian system, okay? So just remember this black dot is our point of action over here, okay? And then draw the force. The force is T, and then we know the angle is 10 degrees, very small angle, okay? And we need to elongate this y-axis so that we can draw the y component over there. Okay, next let's draw the x and y component. Okay, so to do that, you want to draw the line perpendicular to x and y. Okay, always start from the end, the tip of that main force to draw that perpendicular line. Okay, remember in the first problem we draw it from where? From this tip, okay? So it doesn't matter. Sometimes you draw it from the head, from the arrowhead, the tip of the arrowhead. Sometimes you draw it from the other end, like the tail of that force, okay? As long as you can draw this rectangle, it doesn't matter, okay? It depends on where is your origin of this Cartesian system. Here, okay, we draw it from the tip of the arrowhead, draw the two perpendicular lines, and then that's how we find the Tx and the Ty. The direction is very easy to tell because the T is downward but a little bit to the right. So some of the force is going downward vertically, some of the force is going to the right. That's our Tx and the Ty. And now the problem is telling you the maximum force of the vertical direction is 250. So that means you know the Ty has to be smaller or equal to 250 Newton. Okay, and now what is T? Okay, so this is kind of calculation backward, because in the previous case you are given the T and you are looking for the T1 Tx, but now you are given the component, one of the component, and you are looking for the main force. Okay, so how do we do that? You want to first look at this triangle, so you can move the Tx over there to the bottom to make this red. Let me just use another color to make this green triangle, okay, made up by the three forces, okay? And in that green triangle, the Ty is the adjacent side of the 10-degree angle, okay? So you can write it Ty, okay, equals to T times adjacent side, it's cosine 10 degree. Okay, and because Ty is given, it is 250 Newton, then what is T? To solve for this problem, you have this equation, which is 250 equals to T times cosine 10 degree. Okay, how do you solve for this problem? So you want to move everything to the left side, and then you have the T equals to what? Equals to 250 over cosine 10 degree. Okay. Then why do we say this is the maximum tension T? Because here, if you use this equation, we know it's smaller and equal to 250, right? So which means this could be smaller and equal to, and then the T is if you move the cosine to the left side, you're gonna have like t smaller and equal to this value. So this equation will tell you what is the t's maximum, because t has to be smaller or equal to that value. That's gonna be its maximum value. All right, so this is number 2 problem, and then let's move on to this one. A roof purlin. So this is our structure of a building, okay? And then we have the post, okay, 3 posts. It's a cross-section view, okay? So this is a post, and then we have 2 beams. We have 3 beams over there, okay? And then we have rafter, okay? And on the rafter we have the purlins, okay? We have 5 purlins on each side, and then we have the roof. So the load from the roof passes to the purlin, passes to the rafter, passes to the 3 beams, passes to the post. That's how how we track the loads. Okay, so now what is going on here is, if you just zoom in one section of this structure around the purlin, okay, what you have is, you on the purlin, the force from the roof is P equals to 300 pounds going downward vertically, okay, and the point of action is A. So the load passed or transmitted to this small purlin over there, okay, and now the question is, can you determine the components of P, so Px and Py, perpendicular and parallel to the axis of the rafter? This is very important. So it tells you, if you want to set up x and y component, it has to be parallel and perpendicular to the rafter. What is the rafter? This is the rafter. Okay, so that's where we said sometimes your x-axis should be an angled line rather than a horizontal line. So first, let's set up this Cartesian system. So this is the new x. That's parallel to this rafter. Okay, and another one is y. Okay, and you have the force going downward like that, which is P is 300 pounds. Okay, let's don't draw it over there, because there is a line. Okay, so let's do it again. Okay, so perpendicular to the rafter, that is your x. Let's draw it here. X, okay, and then your y. Okay, and then this is your point of action A, and then this is your P. Alright, so now let's just divide it into x and y components. The way you do that, we said you always draw the perpendicular line from one end of that force. So this is our end of the force in this case. And then let's try another color. Okay, so this is gonna be your PY, and this is gonna be your PX, okay? And the next question is, can you solve for the PY and the PX? Okay, we need angle or we need slope. In this case, what we have is just the slope. And the slope is 412. Okay, so what is the other side? I don't know. I couldn't remember this I couldn't recall what is the triplets, so I just calculate from this equation. So the hypotenuse equals to hypo equals to the sum of the square of the two legs, which is 40. So you can write 40 over there. Okay, so now you have a small right triangle, and then you want to find its similar triangle to solve for the problem. To find the similar triangle, it's a little bit tricky here. Okay, you need to find the angles in this, different triangles. What are corresponding angles? Look at this one. Okay, let's say this is angle 1. Okay, so angle 1, if you draw a line parallel to this angle, okay, there is another angle which is also angle 1 because they are parallel line, right? So the x is like that, and the hypotenuse is like that. Okay, so 4, 12, 40, this is 1. If you draw another parallel line parallel to this, this angle will be, they are the same, okay? And okay, so now you understand why this angle over there, why this red angle is 1, is angle 1. It's the same as angle 1, okay? And then let's try another color. Okay, so why this green angle is angle 1? Can you understand that? That's from this analysis. And now let's look at this angle 2. So angle 2 plus angle 1 plus the green angle 2 plus the green angle 1 equals to 90. That's from the observation, okay? Because this line is perpendicular to P, so it's 90. And then look at this angle, the blue angle, because it's a right angle triangle, right? So your angle 2 plus that angle blue equals to 92. Okay, so if you have this and that happen at the same time, which means your angle blue equals to angle 1. Okay, so angle blue is also angle 1. All right, now you already find the similar triangle. So if you move the PY to the right side over there, you can label it as a PY. Okay, so PY, PX, and P make up a right angle triangle, and that blue triangle is similar to this. Now you have to find the corresponding sides and the ratio of corresponding sides. Okay, now look at the PY. What is PY's corresponding sides in the smaller right angle triangle? Okay, so PY is the adjacent side of angle 1, right? This is angle 1. And in the smaller triangle, what is the adjacent side of angle 1? 12. So PY's corresponding side is 12. And PX corresponding side is going to be 4. And the hypotenuse P corresponding size is going to be 40. Okay, and the P is 300, which is given. Now you have this main equation, okay, and then you can solve for the PX and PY. So that equation will give you two small equations. PY over 12 is 300 over 40. So can you solve for PY? Of course. And another small equation generated from the star equation is PX over 4 is 300 over 40. So can you solve for px? Of course. All right, so this is all about the homework. I hope the hints can help you to get 100% of the score for this homework.